Hello, welcome back. Today I'm going to explain how to find the volume of an irregular tetrahedron inscribed in a rectangular prism. Let's begin. A rectangular prism with dimensions 4 centimeters, 6 centimeters, and 12 centimeters have vertices A, B, C, D, E, F, G, and H as shown. Let point P be any point alongside EH. What is the number of cubic centimeters in the volume of a tetrahedron or a triangle pyramid with vertices A, D, G, and P? So let me just mark those vertices right here. So there's A, D, G, and P. Okay, so the first thing you need to know before solving this problem is what a tetrahedron looks like. A tetrahedron is a three-dimensional object with a triangle base and all three sides correspond to the top like this. And a tetrahedron has four faces. Here's one, here's another one. This front triangle right here that we see is the third one, and then here's the fourth one. So now that you know what a tetrahedron looks like, you'll need to know the formula of how to find the volume of the tetrahedron. So first of all, you'd need to know the area of the triangle or its base. And we know that the formula for an area of a triangle is base times height over 2. Next, you would need to know the height of the three-dimensional tetrahedron. So using that, you do the triangle base times the height of the tetrahedron over 3. And this will be base height 1 and this will be height 2. And height 2 will just be the 3D height of the whole tetrahedron. And that should give us our volume. So now that we know our tetrahedron formula, we can find out the different variables needed to solve for the volume. So the first thing you would do is you would need to find out the base of the tetrahedron. Well, if you look at the tetrahedron, there's many bases. For example, this could be the base, a triangle PDG, and then point A could be the top point. Another example is triangle APG could be the base, and point D could be the top. But the easiest way to solve this problem is taking APD as our base. And you'll see why. So now that we have our base, we can find out the area of the triangle. Now you can see in the problem, it says that point P can be any point alongside EH. But even if point P were right here, it wouldn't matter because the area of the triangle would still be the same. The height would be the same and the base would still be the same. So it doesn't really matter where P is. Okay, so now that we know our base is equal to triangle APD, we can use the formula to find out the area of the base. So we know that the triangle's formula is base times height over 2. And we know that our base is 12, and that's because BC is parallel to AD, which means that BC is also equal to AD, which means AD is 12. And we know that the height of our triangle is is 6, because CG is parallel to DH, which is parallel to AE, and they're all congruent, which means that AE is also 6. So now let's solve this. We have 72 over 2, which is equal to 36. Now that we know that our base area is 36, all we need to know is the height of the tetrahedron. Now this is the part where it gets a little tricky. Let's draw out our tetrahedron on the side. So it should look something like this, and it's not drawn to scale. We have our base, which is for this one. Our base is made up of points A, P, G. And our tip the top vertex is point G. And we have our height. So this is a part where we need to take visualization a step further. As we can see, point E is on the same side as triangle APD. It's on this face. And that's where the tetrahedron starts, or it's the bottom. And we can see that point G is the very top vertex of the tetrahedron. And that's also where it ends. And because G and F are both on the same face, this face right here, we can say that the height of the tetrahedron is EF, because that's the length of the tetrahedron, because E is on the same face as the base, and F is parallel to the point where the tetrahedron stops. So now that we know our height, let me use another color. Our height is equal to the measure of EF, the value of EF. We know that EF is 4 because AB is parallel to EF, and they're both congruent. So we know that EF is 4. So now that we have both values to plug in for our formula, we can just do that. So we can do 36 times 4 over 3. And I didn't have to put any base or height 1 value because we already solved for the base right here. So let's solve this. 36 times 4 is 144. So 144 over 3 is just 48. So our final answer is 48 centimeter cubed. That is the volume of our tetrahedron, and we've just finished the problem. I hope you were able to understand and follow through with the problem. This problem is a little tricky. You just need to visualize it, and it's pretty easy to solve once you have that down. Thank you for watching, and I hope you have a good rest of your day.